question you might be asking yourself is, why are we using sine functions for our Lissajous curves for our design and not cosine functions? They are, after all, pretty much the same function. They have the exact same shape, the same period or wavelength, but they just start at different places, right? So why are we using sines and not cosines? So let's explore what would happen if we leave this exactly the same amplitudes, same angular frequencies, but instead of sines, we have cosines. When I first did this, I thought, well, it's going to be the same exact shape, right? See that that's actually not true. So all else equal, if we just change the cosines to sines, or vice versa, we have a different shape. So let's go back to what we had before. What's going on here? See, a good illustration of the difference between the two when we're combining them is the following. So here I'm combining two sine functions, sine 2x and sine 3x, and if we add them together, if we do an arithmetic combination, this is the signal that we get. And we see that if we combine these two cosine functions, cosine 3x and cosine 2x, the signal that we get is this. My thought was that, okay, well, if we add them together, we'll get the same signal, but just shift it over. But that's not the case. If we want to delve a little bit deeper into what's happening here, the reason that we're getting different signals, I'm just going to shift this down so that we can see them at the same time, is that the differences between a cosine and cosine function, or a sine and sine function that we're seeing here, the differences themselves are changing. The gap between the sine and the cosine are actually different throughout the domain of the function, which is why we get these two very different signals when we add them together. So this is sine plus sine and cosine plus cosine. So this gives us a little bit of an illustration as to why when we try to replicate the same shape with cosines, we get a different shape. Because remember, the x and y values of this curve are coming from these equations here. So if the relationship between these 2 points is different for sines and cosines, then we are going to get a different